oxygen, so your dipoles go towards oxygen because it's got the biggest pull. In order for a structure to be polar, it must be covalently bonded and have dipoles. If you don't have dipoles, you're not polar at all, okay? Must have dipoles. A structure is polar overall if a net dipole results. So these dipoles are going to cancel. There's no net dipole. Therefore, the structure is nonpolar. So if when you add your vectors, they cancel, you're nonpolar. You always add the head of a vector to the tail of the next vector. All right. What if we have this? What shape is this? Linear. So now we've got X and Y as our atoms. They don't have the same electronegativity. So what do you think? Are the dipoles going to cancel? They're not going to cancel. So net dipole, therefore polar. So on this one, the net dipole is going to be towards Y because it's bigger. Okay, so you've got a net dipole. That's a very bad arrow. Okay, so net dipole. Trig planar. So all these bond angles are 120. Let's say A is more electronegative. What shape is this? You have to answer a question before.
What shape is that?
Yeah, what shape is that?
Am I allowed to look at my finger?
No. What shape does that make?
A square. A triangle?
A triangle. Are these in the same plane?
Yeah.
So it's trigonal planar, because it's in the plane of the paper. Okay, now ask a question.
In the top one there, why, how do you know that the Y is bigger?
Because I told you.
Oh.
This time
It's like the one's longer than the other? So
yes,
like,
so that's big, that's a bigger dipole.
Oh,
Okay, so that's a bigger dipole.
The green one just to show that it's that way is more polar.
That means if I add these two together, this is only gonna cancel this much. So the net result is gonna be in that direction. So it's like this. I've got,
So would you actually draw it like that or no?
yeah, you can draw it like that.
So you add the net dipole thing to it?
Yep. Yep. So if I go this way first, then, because you're doing head to tail, you're now going back this way. Did I finish at the exact location that I started? No. So your net dipole goes, the tail is from the start to where you finish. Okay? That's how you add your vectors. Now this one is nice because it's actually symmetrical. When you have a symmetrical structure, like triplanar, linear, if you cut it down the middle and it's the same on both sides, it's going, all your dipoles are going to cancel. So this one, you have a dipole coming this way, and you've got a dipole going this way, and then you've got a dipole going that way. So you are back where you started, so there's no net dipole. It's exactly it. It's a resultant vector. So no net dipole, therefore non-polar. The dipoles cancel. So you're asking me if you put these on?
Yeah, no, like, yeah, like if you're on a test, which like, and you say like do the polar or whatever, do you like write them still?
You should still put them on.
And then just say it's not polar?
And then just say no net dipole.
Okay,
Yeah. Because otherwise you don't have any work to show,
yeah.
right? So this has a net dipole, so it's polar. Yeah?
Does it matter like how you go about like the order of the
No.
videos?
It doesn't matter at all as long as you use all three.
Okay, so even if you went like the blue, red, blue, it's still like the same?
So which one do you want to start with? We'll number them. 1, 2, and 3.
You did 2, 3.
So 2, 3, 1. It's not going to matter the order, as long as you use all three.
So if they cancel, do you still write the dipoles down? Like
You
on the
mean
test or
these?
something? No, like on like the other one that you did. Like they
These?
cancel. Like the ones that actually cancel. Like those don't cancel. Like if it's not
Are you
just-
asking me if you put these on or these
No,
on?
no, no, like the question before.
The question
Like one
before.
where like there's no net dipole.
Okay. This one. This one's a little harder to show because now we're getting three-dimensional, right? It's coming out of the page, it's going behind the page. What would happen if I had one going down and back and one going down and front? They would cancel? Do you guys agree?
They just end up in the same place they started.
If I go down this way and then I add down this way, would I not be further down?
But like, oh, you're not talking about like this way and then back this way?
Yeah, no, no. Because these guys go down, right?
Yeah.
I'm going to just save you some trouble here. Tetrahedral, equal dipoles, symmetrical, no net dipole. Okay, tetrahedral. Symmetrical, no net dipole. It's really hard for you to draw the dipoles for this one. Okay? So if it's tetrahedral, like CF4, CH4, symmetrical, no net dipole. However, this is not symmetrical. Therefore, net dipole polar. Okay? This goes back to a rule that I taught you last year. And you guys had to remember two groups of chemicals that were always nonpolar, everything else was polar. And you're all looking at me like, okay, so what was it? Because we don't remember. Am I right?
Yes.
Page 85, Table 3, grade 11 textbook. So, diatomic elements. Do you remember what they are? Hofbrinkel.
Sauce. The mid.
Hofbrinkel.
Oh, I remember this now.
Okay, yeah. Diatomic elements, not diatomic compounds, because you can have diatomic compounds. HBr, HCl, ClBr. If you have two elements that are not the same, it's still diatomic, but it's not an element, because they're not the same. Okay, so diatomic elements, difference in electronegativity is 0. Therefore, they are polar or nonpolar? Difference in electronegativity is 0, nonpolar. If you don't have dipoles, you can't be polar. Okay, the other one, carbon bonded to one other element, and there's an even number of that element, nonpolar. And this is why, right? If it's tetrahedral or linear, then you've got dipoles that will cancel, or no dipoles at all. So carbon bonded to one other element, so we're talking like an X, and there's an even number, like 2, 4, right?
Carbon bonded to anything, that's an even number?
But only one anything.
Okay, so it could be like C,
PO.
CPO. If there was something CPO, would that be polar or nonpolar?
add it to.
No, that's polonium.
Oh, you wanted polonium, did you? Well, then you're getting into metals.
That's true.
So that's not covalent. But let's say it was something like this. Would this be polar or nonpolar? Polar. Because there's 3 elements. Okay. How about this? Polar or nonpolar? Nonpolar. How about this? Nonpolar. How about this?
Non-polar.
Nonpolar. 1 element, even number. How about this? Polar. CH3CL. Polar.
It's 3 elements.
Because there's 3 elements. Okay?